Good day everyone, my topic for today is all about design to manufacture. A 3D experience work story of DTV shredder. I'm Jerby Anajao, application engineer of Computrends. BPG Works based out of Ontario, Canada has been tearing up all the terrain vehicles with their dual track vehicle, the DTV shredder. This precision machine harness over 530 components that propel itself and its pilot to a ripping 25 miles per hour over almost any terrain, with 800-pound towing capacity and impressive 35-degree approach angle. One of the remaining design requirements is the platform for the rider to stand on while operating the shredder. This board is intended to be designed so that the rider is positioned laterally to the twin tracks, similar to that of a skateboard. The shredder custom chassis will create some constraint for the overall design, from rider stance, foot traction, and manufacturability will also need to be considered during the design process. Current design, the board is directly mounted to the chassis through some fixed brackets. They need to change the design in order to modify the steering controls and improve the overall readability. To take this on, a proposed pivoting system will replace the existing fixed connection, so allowing the board to rotate 30 degrees plus or minus 15 degrees from its neutral position. So in that case, they need to add bushing to provide resistance to the rider lean. Okay. So the pivoting system needs to connect to the existing CVT transmission. As the pilot rotates the board, a linkage will engage and disengage the left and right transmissions, giving the rider full control of track's power. The final design should be like this. While the engineering and design team are working to complete the board, they need to consider some machining requirements. They need to consider if this can be manufactured in-house. This not only save on lost time with supplier lead times but reduce overall cost. Throughout this story, you will see a precision collaboration highlighted between the core design, engineering, manufacturing, and project management teams, all showcased through the 3D experience platform from the source system. This is the part of the team. Team from design, engineering, and manufacturing. So I will start with Pete. So Pete is a team project manager. He is there to keep everything on track and moving towards a common goal. So Dan is a true motorhead and is known for his outside-of-the-box approach. As a certified SOLIDWORKS professional, Dan knows the in and outs of SOLIDWORKS CAD design. So Eric brings expertise in complex mechanics. His responsibilities focus on critical part and assembly design. Next will be Sam. Sam is the team's manufacturing engineer. His responsibilities include overseeing all in-house manufactured parts along with working with outside manufacturing suppliers and vendors. So we will start with lean team meeting. When it comes to meeting, keeping individual on track while efficiently and effectively collaborating as a team can be a difficult task, especially with more and more employees finding themselves working remotely. So having well-rounded contribution from meeting attendees, we need to know how problems to be solved, and then the 3D Lean helps to solve that problem. So let's see how Pete, Dan, and Eric make the best of use of their time as they jump into a 3D Lean team meeting. So Pete starts his day by logging into 3D Experience platform and accessing the company's customized dashboard. So he needs a few minutes and to review collaborative community, a much more intuitive way to share and communicate with coworkers. So this is the example or user interface of Lean team meetings. Okay. So Pete sees that it's about time for this week's project meeting, so he navigates the team meeting tab on his dashboard and sees that Eric and Dan have logged in remotely and ready to contribute. So 3D Lean offers unlimited option for creating customized boards. For this call, Pete used virtual sticky notes directly on taskboard to record unsolved problems and recommended actions. So he records some possible actions. Pete can assign individuals to each of these items. Eric for the pivot designs, and then Dan to take on the board design. So Pete navigates over the team actions log where each action note have been populated from previous board. He moved this into the tomorrow bin track to track expectation on each task and when they will begin. So 3D Lean boards can be customized for all short discussion, including sketchboard. So Dan start to sketch his idea, and then Dan asks questions to collaborate to the team. Dan's input from his tablet is immediately visible to everyone through 3D Lean without any third-party screen sharing application needed. So 3D Lean captures all the relevant information from this meeting in one spot and can be organized into a simple to follow presentation format for playback or for preparation for upcoming meetings. Next, we will go to the part design. So 3DEXPERIENCE SOLIDWORKS offer powerful 3D modeling capabilities for every level of designer to create manufacturable components and assemblies. So let's see how Dan used the intuitive tools in 3DEXPERIENCE SOLIDWORKS to create an ergonomic board for the shredder. So Dan begins by searching for project. A keyword for the term shredder brings up all relevant documents. So convenient filters allow him to narrow his search to only top-level assemblies, making it easy to find what he's looking for. Dan uses the slider to choose the lightweight mode, which decreases the time required to open the project and also improve the performance of the assembly. Dan hides components he doesn't need to allow him to focus on his design. And then Dan import this sketch image and resize them specific dimension. Okay. Import these images and then resize. This is a great starting point for the board design. Adjust the sketch or adjust the images. Then start by constructing a standard spline. Dan turn on curvature comps to gain a deeper understanding on boards. He converts it to a style spline, which allow him to create relationships to construct entities, making it easy to get the exact shape he's looking for. A simple arc can be used to create the profile for a swept surface. He applies an ABS plastic material as he expects this part to be injected molded. Okay. Also, Dan wants to make sure that the new board will attach the assembly at the existing mounting points. So he can reference the footprint and hole pattern for this bracket to ensure the perfect fit. In 3DEXPERIENCE SOLIDWORKS, Dan drag 3D textures onto the face of the part. Dan can adjust the 3D texture sliders in order to refine the textures until he's happy with the results. Now that the board design is complete, Dan communicates his work to the rest of the team by saving it to the 3DEXPERIENCE platform. Next, finally, Dan changes the maturity of the board to Frozen for review. We've seen that Dan used 3DEXPERIENCE SOLIDWORKS to create a manufacturable board design. Next will be the assembly design. So let's see how the power of SolidWorks assemblies speed through this design process and ensure the new steering control system works flawlessly. So we catch up with Eric after he's already created the steering track mechanism that allows the board to lean, and pushrod assembly that controls how much power is being delivered on each track, which steer the shredder left and right. Now, Eric's job is to figure out how to translate the rotational motion of steering track to control the linear actuation of the pushrod. So, he will be making changes to the design. So, he starts by reserving the assembly. Okay, so he need to reserve the assembly since he doesn't want to step on anyone else in this process. Okay, reserve. And then in previous project, Eric used a tie rod assembly for similar mechanism. So he does a quick search. So he does a quick search for this mechanism or tie rod. So he can see that there are few sizes. So he choose 170 mm tie rod. Okay. So he need also spherical hinge tie rod. So he make a quick copy. And then next, he will create mate for these sub-assemblies. Okay. Now to assemble the rod and steering track, he need to click any faces and then any circular edge and then just doing the mates. So by making adjustment, wheel transparent, he can now click the cylindrical face of the rod end, stud an inner face of the curve adjustment slot. He used the slot mate, which constrained the stud to only be able to move within the limits of the slot. And then he used the component preview to mates the other parts. Okay. And then he continued to add mates for the design requirements. Adding coincident mate, then exit the preview. And then next, he need to change the configuration of this rod. So you choose the different sizes. Because the rod is short, he select 195 mm configuration. And then after that, testing the mechanism. So Eric can see that it's working just as he had hoped, but knows that it will need to be tuned to ensure the proper function. At the center position, the end of the pushrod will need to be right between the left and right drive or the drive clutches, giving equal power for both tracks and making the shredder to go straight. So next, by zooming on the end of the pushrod, he sees it's too long. So he used the measure tool to measure the distance from the end. Okay. So it appears that the pushrod is 4.25 mm too long. So Eric creates a sensor so he can save the measurement and access it anytime in the future of the design changes. So Eric also created 2 additional planes on either side of the neutral plane, okay, which correspond a hard right turn and hard left turn. He opened the sensor he just created and moves the pushrod through the entire range of motion. So Eric can see that the end comfortably hits the turning limits and it's beyond the 1.25 mm specification. So without any building testing a single prototype, so Eric developed a mechanism with which control the steering by simply leaning on the board. And then Eric will save these changes to the cloud. Okay. And then unreserve. After saving, you must unreserve it. Okay. So next, we will go to the validation. Eric already assembled the new steering mechanism and validate its motion, but Eric will test different shapes and nonlinear materials for the rubbing bushing. So let's check where the bushing located at. So the current design uses a simple block, but he has a couple different ideas under consideration. A B shape designed to buckle into itself and another shapes, leveraging an elliptical cutout. To test and compare this variation, Eric will use his simulation apps on the 3DEXPERIENCE platform. So Eric prepares the model for inefficient simulation studies. So he removes small features like hole, pockets, and fillets without modifying the source geometry. So he used what we call defeaturing to remove fillets and reduce with a radius of 5 mm and smaller. And another that removes holes with a diameter of 8 mm and smaller. Next, and additional tools are also available to remove phases of interest to simplify the model further. Okay. Next, we have the continuing the study. Eric leveraged the powerful of contact solver of Abacus by defining general contact, or what we call general contact interaction. With this, there's no need for Eric to guess and check where components may come in contact. So it's detected automatically and solved efficiently. A clamp to hold on a bottom place. Okay. And then next, a hinge that allows the top to rotate the fixed displacement for selected translation and rotation to represent the 5-volt bolt or the fixed displacement. Next. And applied rotation of 15 degrees is defined on the top of with a predefined amplitude that enable Eric to specify exactly how and when components will move. Okay. Before Eric can solve his scenario, he defined a mesh to accurately capture the geometry. After solving the analysis, Eric jumps right into the results and see the excessive displacement of the rubber bushing along the axis of rotation. So he toggles the contact pressure plot to quantify his discovery. Okay. And concludes that simple block just won't work. Okay. In similar fashion, Eric toggles to the result of B-shaped bushing. This design shows improvement. So Eric takes a closer look by changing the transparency and visibility of components in his view. Next. So the displacement and stress are looking better here. So Eric creates a XY plot to graph the reaction moment of the applied rotation to reveal how much force is required by rider. And also, with variation to create geometry and material, Eric can quickly compare the performance of his designs, ideas, and move forward with the best designs. Next will be the issue and change management. Whether it's lagging manufacturing, concern from shop floor, or problem submitted by the end customer, capturing critical issue is key to evolving your design. With the 3D Experience platform, simplifying how these issues are captured, reported, and tracked can dramatically streamline this process. So let's check in the team and see what happened when some identify a possible interference issue and how Pete managed, reviews, and assigned this issue to resolve. From Issue Management tab located on Sam's dashboard, he accessed to the entire CAD assembly. In Issue Management, Sam will input the title of the issue. He will type the title of the issue, and then Sam put the description on the issue. And Sam also uses the recommended resolution to identify the possible solution. And then the next step is to Sam to attach this issue directly to the affected component. This assembly has lots of components, so the selection tool make it easy to identify the assembly or subassembly, or in this case, single part to attach the reported issue against. You can assign co-workers of the issue as well as the assigned people to the issue. Then issue is created. So once issue is created, it will notify all the member of the team. Within the same issue management tab, okay, so Sam navigates to the field issue to include 3D markup to add a visual reference to the problem. So he starts creating a markup. A new markup is created and the assembly is loaded. From here, Sam begins to create individual slides to illustrate where the interference is likely to occur. And then multiple tools are available for creating this type of markups. And with the pen option, it makes for quick work. A few lines to indicate the area of interference and additional callout added. Here you can type any callout. Type any callout. Okay, so that they will see where's the problem. Sam saves this new slide in the 3D markup. Accessing the side view, the process is repeated to indicate the current motion designed into the handlebar storage position. Next, once issue is properly marked up for identification, you can attach those captured images, then update the issue. Okay. Attach and then update the issue. So it Pete's turn to review and create any necessary change action and keep the team moving forward. It's from Pete's dashboard, enabling the issue flags gives a color or a color code reference for each issue submitted, location, and status. Here we see the orange flag, which indicates Sam's recently submitted issue. So Pete verify the issue and check all the reference component that might be affected. So Pete see this is as a major concern and doesn't waste any time issuing change action against the board to resolve the interference. So opening the issue, you will see all related objects into it. Then you can add new action. Type the new action description and then change its severity. After that, severity is high and input the due date. So Pete will move this into an in work and update the priority to urgent. So now that the issue has been reviewed and change action has been filed, Dan will take over. Dan receives a notification and navigates over his view of issue that he has been attached to, where he can also see the assigned change action. So navigating to the affected part, Dan launches 3DEXPERIENCE SOLIDWORKS and open the part right from his right-click menu. So he opened the 3DEXPERIENCE SOLIDWORKS. He will change the maturity of the board design to restart work. Okay. After restart work, then the new revision. Okay, click the new revision. Start to revise the part, so he need to click the reserve. Next, he will use the section view to identify where's the problem. Then next, then create a solid from a profile and add some fillet using the convenient selection helper. He used the indent feature in the 3DEXPERIENCE SOLIDWORKS, so allowing them to preserve the board thickness while creating the clearance necessary for the articulating arm. So Dan checks the fit one more time. Okay. And it's perfect. Then he will save the file in the cloud. Okay, and create some comments, and then you can release the reservation after save. Okay, and then change the maturity from in work to release. Okay. Next. Design to manufacture. Shop floor programming. The 3DEXPERIENCE platform extends the capabilities of your engineering design data. Some needs to machine truck arms for DTV shredder. Okay. So he gets started right from within the dashboard using the power of Delmia's shop floor programming apps. Okay. He gets started right away from within dashboard using Delmia. So some able to simply search for the product to get to work right away. So you just need to search the product. After searching it, he will open the part. Okay. Some likes using the shop floor machining wizard because it simplifies the task of setting up his working environment. So defining the machine. First, defining the machine. Next, defining the tooling that is available on other settings. Okay. Select metric tools. Also, defining the numerical control of your machine. The wizard helps him to determine the appropriate stack size, but you can edit the stack size based on the standard material size available in your company. Okay. And then input the XYZ stack size based on your requirements. Some leverage the what we call hole feature recognition, which capture the diameter and depths of all holes on the part. This will eliminate the need to interrogate the model to determine the correct tools to use later. So some set to work on roughing on part. Okay. So we start roughing. So he used the 20 mm by 100 mm flathead for wrapping. Okay. Select the tools and then click OK. So he changed a few settings to optimize this operation, and let's roughing tool to do the rest of the work. Okay. Once calculated, he can review the toolpath to ensure it performs the way he was expecting. So you can review the toolpath. So we have what we call toolpath simulation. Okay. The last step for this setup is to finish all the rough surfaces. So some use the advanced finishing for this task over the entire part. This process will clean up any rough material left and will precisely finish all the other surfaces. Okay. So we use the advanced finishing. Okay. In this case, we want to limit the time intensive process to a specific region using limiting contour. Finally, he received the entire machine process of the complex part, so you can look for any potential problem in the last check. So, satisfied with the results, all the left is to output the NC code, then fixtures this stack and start making chips. Okay, next, the project completion. So this is the 3DEXPERIENCE SOLIDWORKS design team. Pete will update company lean and team board. Okay, all work put into complete tab. And then update all the issue to done. Okay. Next, change the maturity to release, and then inform the team using what we call 3D Swim community. So he informed the team about the projects, then publish. So 3DEXPERIENCE work, we have lean team meeting. It quickly build meeting agenda, highlights issue and challenges, capture action and our assignments. And then we have parts assembly design. We have lifecycle data management on cloud. We have seamless design collaboration. And we have powerful yet easy to use sketching, 3D design, and assembly capabilities. And then in validation, we can leverage CAD design for virtual simulations, industry-leading simulation solver for complex materials and contacts, and then understand how ideas will perform virtually to help improve upon designs. And then in issue and change management, we can collect, monitor, and process reported issues, visual 3D markup to clearly communicate problems, and then quickly overcome problems with engineering change actions. And in manufacturing, streamline the bridge from design to manufacturing, reduce scrap under work, and shorten the full manufacturing process, and then plan, detail, simulate, and optimize machining activities. Okay, that's the 3DEXPERIENCE SOLIDWORKS. So thank you for listening. If you have any questions, please follow our Computrends website and email us if you have any questions. Thank you.